Recording in progress.
Everyone, this is what I want you all to do. I want you to check your answers and circle up whichever question that you got wrong and look at your mistake. If you don't understand your mistake, we'll discuss the answers before we move on to 1.3 and 1.4. So for 1.2, check the answers first. You're telling me went home for an hour to sleep, and invest.
1个小时的睡觉时间很珍贵的。
Okay, everyone, done to question 11. Correct. I think for the first one, I give you until question 22 only, right? Come on. Oh, you don't do correction first, 改完了吗？ Check your answers first, and then we'll discuss the answers later on. 到第几啊你？有 glasses， 你看得到吗？坐那么远，你看不到你就坐这边。啊？ Okay, guys, let's go through the first 10 questions, guys. Anyone got any questions for the first 10 questions? Anyone couldn't do any particular question from the first 10 questions or not?
One, two, 5, 7.
Wow. Okay, looking at question number 1 here, what's this? You have km and minutes, right? And you're asked to find the average speed. First and foremost, can I do 60 divided by 20? Can I? Why not? Okay, what's the formula for average speed?
Oh,
Over. Then can I do 60 over 20? Why not?
You have to convert.
Good. Not only do I need to convert minutes to seconds, I need to convert one more thing, right? Look, your answers are all in meters per second. That means to say this thing should be converted into meters, which is 60,000 meters. And this thing should be converted into seconds, which is going to be 126 seconds. Is it? Yeah, I think so. Yes. So our answer should be C, right? Where is it? Make sure you look at the units properly before you do your calculations, guys. This is very, very important. Okay. Down again. Welcome. Okay, then for question number 2. Let's see first. It says that 2 runners take part in the race. The graph shows how the speed of each runner changes with time. One runner runs at constant acceleration and one runner runs at decreasing acceleration. So after that, they ask what does the graph show about the runner at time equals to t? You look at the first answer, say both are moving at the same speed, which is essentially what's happening here. Right? Look here. At this time equals to t, runner 1 and runner 2 is running at this exact same speed, right? So the answer should be A, what? Right. You said that the answer was what? The donkey, the runner is slowing down. In order for the runner to slow down, shouldn't the speed decrease? But at this point here, which part of the speed did it decrease? Right. So at no point is the speed decreasing. So donkey is definitely not the answer. Okay?
What's the answer from the one?
C. Then, after that, what's the next question? 5, you say? Question number 5. What is this? A car travels along a straight road. The speed time graph of this journey is shown. During which label part is the resultant force on the car 0? Okay, this one you haven't learned before. But let me tell you right now, this is exactly what we're going to learn today. Resultant force 0 usually means to say that acceleration is going to be 0. If anything has 0 resultant forces, it means to say the acceleration is going to be 0. And at which point is the acceleration 0?
Boy.
Yeah, and boy is the acceleration is 0 because it's moving at constant speed. Wait, I'll let you check the answers later on because we went through the answer. Now we're going through the questions first. Okay. What's the next question after that? Number 7. This one also same thing, right? It says that you have average speed of this. This is in km per hour, and this one here is in minutes. Can I divide it like that? What do I have to do with this? Change it to seconds? No. Good, I have to change it to hours. 15 over 60 is equivalent to 0.25 hours, right? Right, then after that I have to use, how do I find the distance given this and this right now? What's the formula? Equals to? Okay, so if I'm looking for distance, it will be equals to? Good. which in this case here will be 60 times 0.25, which is going to give you back 50. Okay. Okay. Anyone else with any questions for the first 10 questions? Anyone else? How about the next 10 questions from 11 to 22? Anyone has any questions from 11 to 22? From question 11 to 22. Anyone couldn't do any particular question? Question 11. A geologist compares the volume of three rocks X, Y, and Z. The three measuring cylinders contain different volumes of water. He placed the rock in one of the measuring cylinders. The diagram shows blah, 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 blah. So I have volume X, Y, and Z here, right? Which row gives... How much is the volume of X? So this one is 50, right? Then this one, this is 什么减什么？这个是几多？ Yeah, this is 78, right? And this one will be 27. So this one will be 51, right? And this one, 79, right? And this one is 33, right? So this one will be 46. All have different volumes. So what was your answer? The last one. Make sure you know what's your mistake. Okay, next. Next, anyone? A car travels 100 km. It takes 2 hours. The highest speed is 80, the lowest speed is 40. What is the average speed? What's the formula again for average speed? What? It's not distance over time. Average speed. Total distance over total time. Right. And this here, how much is the total distance? How much is the total distance? 100. How much is the total time? The answer should be B, right? Okay, next. Anyone else?
What's the question 17?
Question 17. Very good. What's this? A tennis player hits a ball hard and 0.4 seconds later hears an echo. Oh, you haven't learned this yet. This should not be here. This is echo. But if you think about it, if you must know, right? Let's say imagine this is the wall. It says it hits the ball and 0.4 seconds later it hears the echo. The sound has to go like this, then echo back like this, right? This duration 0.4 seconds. And speed of sound is this. How far is this? How far is the wall away? So you're supposed to use speed equals to distance over time. The distance that the sound travels is going to be speed times time, right? Which is going to be 330 multiplied by 0.4. But if you find this distance here, you'll get somewhere small number. You can someone press the calculator. 0.4 is how much?
The final answer 800.
No, definitely not. How can you get 800 and something?
I think I used the wrong method. Because instead of 330 times 330 divided.
And this is not the final answer yet, by the way. How much is this? 330 times 0.4? 132. This 132, you need to identify what is the distance traveled. Because here to here took 0.4 seconds, right? It means to say from here all the way until here was 132 meters.
So you use that times 2.
Still times 2?
No, 132 like past. Because like
Uh,
people here,
yeah. What's the question one from you? How far is the player from the wall, right? From here to here, right? So what should I do with 132? Yeah, so you divide it by 2 because this distance was 132. That means you say here is 66 and here is 66, right? To be 133. You understand now, David?
and
Okay, any other questions for this part here? Okay, everyone. I'll let you check the answers later, David. But we move on to 1.3 right now. Check answers for 1.3, guys. Why?
listen, at least the urge is like make sure everything is not.
Check answers, guys, for the 1.3, this one.
It's also convenient. It's going
Wait, let that be. Everyone done to question 13?
both glories.
So, this is not a question, it's not what前面这里，你过来做前面这
Maybe
里。
it's not requested.
No,
This
she's like. 可以了吗？confirm 吗？It's not a request. Okay, question 14 onwards to 20. Is there any more? Oh, there is.
15. What? Oh, it's about 18B.
It may be wrong. Some of the, if I remember correctly, some of the answers may be wrong, but we'll highlight that later on. If you have a question later, just circle it and we'll discuss the answers. Okay, everyone? Done? Okay, guys. Anyone with any questions? 10? Question 10, is it? Question 10, what's this? The mass of an astronaut is 70 kg. What is the mass of the astronaut on Earth? Wait, this one, what's your answer? B.
How does it like? Is it 10 or 9? Because like I mean the seduce is.
Bro, but this one got nothing to do with gravity. They're asking you the mass. Mass is the one that does not change, right? Because why doesn't mass change again, Jivan? It's the amount of matter, bro. Remember, mass is the amount of matter in your body because you matter. Wait, were you here during that class? Oh, you weren't here.
There's some factors like I don't know, very very weird screenshots like that. Subtitles It's so weird.
Don't watch it with the subtitles.
It's like-
Remember, mass does not change how they learn. Mass does not change because you matter. Alright, remember. And because of that, no matter where you go, your mass will be the same. Next question, please. Oh, no next question. Seriously.
I think watching.
A child sits on a rubber ball and bounces up and down the ground. What stays the same when the ball hits the ground? The acceleration of the ball, possible. The mass of the ball, for sure. The shape of the ball, no way. The velocity of the ball, no way. The acceleration of the ball. Oh, it won't be the same because it's bouncing up and down. When it goes down, it has positive acceleration, and when it goes up, it's negative acceleration. So B is the only logical answer. The mass, once again, because. Very good. Okay, you just now say what? 15 ah?
Yeah, a question 15. Isn't it supposed to be more? Because like they say the unit of force and weight is newtons per.
It is. Force and weight is the same thing.
Oh.
It's in Newton, which is what you're going to learn in this week. Okay? Wait, Daniel, you're all fully quiet. You got everything correct, is it? Oh, what? Oh. Yes, you weren't here last week. Okay, never mind. Moving on. Next. Anyone?
17A.
What? No. How can it be A? What's the formula for density? Wait a minute, have you watched my videos yet? What's the formula for density?
I remember this. Density equals mass over volume.
Oh, it's mass over volume, right? Mass is in kg, volume is in meters cubed. How can the units of density be measured in newtons? It's kgs per meter cube, isn't it? Bang. Thus, it should be weight. Okay. Anyone else? Going once? Going twice? So, final one. Check answer. For the density one. Also until system 22 only. Did your brother tell you I saw him again that day on you? Where's Duncan?
Oh, Duncan never.
He just didn't come today.
Didn't come today. No. It'd be really funny if he like didn't come because like he was trying to do something very dumb.
Such as?
Such as? I don't know. I'm just suggesting. How would I know?
Wait, because it's a rusty thing. I got quite a few rusty students that didn't come to.
I mean, I could ask him he could be gone for 1 month and just say, where do you go? I had to go do stuff 1 month.
Poker face guy.
Poker face, yeah. 19 straight poker face all the time.
Okay, everyone, done with the first 11 questions. You saw 11 questions.
这怎样？我要查啊。
Not hurry up. until 第几题啊？这个？哦，until 20吧。Okay, good.
我可以从前上的那个考试里，
Sorry?
like meeting board.
Oh, really? Okay, no worries about that. Okay, everyone done? Done checking answer? Okay, guys, anyone has any questions or not for this part here? Anyone? Again, 我看你都爽，你了。啊？
Alright, so
你不要这样子嘛，你好像要睡觉睡这样子，那你可以学习到东西啊，那你可以学习到东西。
对的，所以我刚才来有在练习。
Alright, guys, anyone any questions or not for this set before we move on? 15. No. What? This one? Calculate the density. Mass over volume ah. What was
But then the answer will be though.
answer was B.
Ah.
Oh, it's definitely not B. It's donkey. Mass over volume, what, right?
Indeed.
13 not this. Volume, mass, density. How is the density? So you have to find this density first, right? Which is mass over volume, which is 0.85 gram, right? So this liquid has lower density than water lah. The density is higher than water. No, the density is lower than water. It's wrong. And thus, don't trust the math scheme 100%. Use your gut feeling also, guys. Okay, anyone else? Any question? 16. The diagram shows an empty measuring cylinder, the same measurement, blah, blah, blah. What's the density of the liquid? What was your answer?
C, because the mass density going to volume is 10 centimeter cube one. Then it's mass over volume density equals mass over volume one, then you get 2.
That's correct. What was the mass scheme answer?
Donkey.
Oh, that's wrong.
Man.
Once again, don't trust the math scheme. If your gut feeling is telling you, then most likely you're right. In IPCSE, I've seen the wrong answer also before. So, like very rarely though, like maybe once every few years. Metal X and Y hang from a spring balance as shown. The diagram shows, what does the diagram show about X? They have the same mass and same volume for sure no they have the same mass and same weight but different volume, very possible. Same mass, same volume for sure no. Same weight and sure no. What's your answer? Why would they have the same volume? They are different. 都看都看他们不一样 size 怎么可能会有 same volume?
Wait, but then I saw the answer is B. Oh my god.
Answer is B?
Answer is that.
Yeah, for sure. Okay. 18. Measuring cylinder has a mass blah 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 when empty, when it contains blah 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 blah, density equals to mass over volume, which is 40 divided by 50, right? A. Was the mark scheme wrong again for this one? Is it? Let's check. Measuring cylinder contains liquid, the apparatus overlay, blah blah blah. So the mass was 8 and sorry, the volume was 8. The mass was 7. Right, yeah. 7 over 8. How much is that? 0.875. Okay.
哦，我抄了这么多，只有这个答案是对的。我都抽掉过那个马克思。
Don't know.
Who make the markings? 他是给我们一个提示选项，就是排除。
排除法
Yeah, it's like they give you a wrong answer and you have to pick the correct answer from the other three.
Okay, guys. Any other question for this one? This one the masking was correct lah. Is it? Then what was your answer? 你知道为什么吗？因为你要for this question here, you're supposed to find out how much is the mass from the evaporated volume. From the evaporated volume, 它 evaporate 了7个 gram 嘛，在这边对吗？然后这边到这边它 evaporate 了8个 cm cube 啊。So I know that 这个8个 cm cube 其实是7 gram 罢了啊，你明白吗？ So mass over volume 就找到和 A 了这个。And for 20, which two blocks have the same density? 哇，全部要找来 density. Mass over volume, which is 10 divided by 8. This one will be 10 divided by 12. This one will be 20 divided by 16. This one will be 20 divided by 8. So 看哪一个是一样 density 的 P and R. Yeah.
哦，这个错的。
不要相信 Maxim， 相信自己。
啊，没有。
Okay, everyone. Any other questions from this part here? No, then bring out your book.
他这个答案准确率就是我自己猜的高。
哪一个不对？
对，在那里。
Okay, guys, bring out your book. We'll move on to a new chapter today. Okay, guys, if you look at this new chapter here, basically what we're going to learn is everything related to forces. Forces chapter here. Yeah. Okay. Let me give you a quick run through of what I hope to cover today. Right. I'm just going to cover 2 pages only today because I don't think I have enough time to do the rest. We're going to learn about effects of forces, which you have already learned before this, right? if you think about it, effects of forces could affect the shape of the body. For example, if you play with clay and you crush it, right? Now obviously it changed the shape already, right? It could affect the size of the body as well. For example, a balloon, if you use force to press it, then it could change the size also, right?
So like the balloon is filled with air very big, right? If you press it like against balloon, it explode.
Yeah, I mean to before breaking point lah. But even if you explode it, then the size goes from this to nothing, right? So it could change the size also, right? So the third one is speed of the body. For example, if you're running, right, and then I push you from the back, you're going to accelerate forward, right? But if you're running and I push you from the front, let's say for example you're running, I mean I push against your motion, then I could decelerate an object also, right?
我试过用摔到，
But that guy for sure 也是 slow down 了，因为他的 speed 被 transferred to you 了。You know, so 他的 speed 一定是 slow down 了。
if very push me up. Yeah, if anything.
That's true.
Yeah, but your speed is changing.
It's the essence. My face.
Really, you guys never tried this in school before. Try, ask you start running, and then your friend run behind you, and then just push you. I mean, no, actually that's very dangerous. Don't
Yeah.
you most likely fall.
我试过摔到吗？
So you But anyways, the speed will change for sure, right? You could either accelerate an object or decelerate an object. And finally, of course, the direction of the body could change also. For example, if I got one car driving here, then one lorry come in and smash it. Obviously, the car will either be changing into a different direction or smash it to 1,000 pieces. Yeah, and could possibly change everything. So it should yeah. So this is that. Okay. Then after that, we're going to learn about Hooke's law. I'll go more detail later on. Hooke's law is basically everything related to a spring. Very important. Right. And finally, we're going to learn about the force and acceleration formula. Like I mentioned just now, you must have some form of resultant force for it to accelerate. If an object is not accelerating, usually it means to say it's zero. Right. If the force, if you have no force acting on an object, it would very mean that it's not accelerating, which could either be zero acceleration or what you are experiencing right now, zero speed. Okay, so it's either one of that. And this is one of the examples of that. Okay, so having said that, let's go through this Hooke's law first, because the force one, everything you know already. If whenever you see the word Hooke's law, guys, oh. Okay. But guys, whenever you see the word Hooke's law, I want you to straight away think about springs, guys. This is a very important thing, right? And whenever everyone here played with springs before, right? Anyone never touched a spring before? Anyone? You know, right? If you play with a spring, you elongate it, let go, it will bounce back. You elongate it harder, let go, it will bounce back harder. But if you elongate it too much, it won't break out. But you see that the spring kind of point on already. Right? Yeah. You guys play with, you don't know what I'm talking about. Anyone can, if you don't know, right, open up your pencil and smash your pencil until the spring comes out, elongate it, let go, elongate it, let go. And elongate it too much, the spring will point on all the way. Yeah, it's deformed already, right? So Hooke's law is basically talking about everything like that. If you think about Hooke's law, right, I want you to first think about a graph, guys. Hooke's law's graph looks something like this. It will usually be a force, which is measured in newtons, against a extension. Okay. Extension graph, which is usually in meters. Okay. Hooke's law, right, will have a graph that looks something like this. It will be initially one straight line first, until it reaches the breaking point. The breaking point is what we call the elastic limit. Yeah. Elastic limit 就是说它还是 elastic. Elastic limit 就是它 no longer behave elastically.
So it's rubber elastic.
Yeah.
我不知道 elastic 是什么，我说 elastic。
Elastic 是 for example 这个东西 you see 这个东西是 elastic 的 ，because I can like kind of bend it and it go back into shape 的 ，right？ 这个东西不算是 elastic because no matter what I do to it, it will retain its shape, right? Like this thing here also is non-elastic. This paper is non-elastic. Anything that is elastic will be usually like for example 这个
I mean, if you cut enough, you can change the shape.
that's not called elastic. Like for example 这个东西 right, you can bend it, you can kind of bend it, right? This is what we call elastic, right? 可是 if I bend it too hard, right, it will exceed its elastic limit, 它就会坏了。这个也是，如果我赶着这样子 like all the way 啦 ，press it all the way to the other side, right? 它一定坏了 ，because 它 exceed 它的 elastic limit 了。Spring 也是一样。
我知道是什么意思。
Yeah, so spring 也是一样，它会有一个 elastic limit. Once it exceeds the elastic limit 啊，它的 graph 就这样子了，它就这样子 bend over 了。Right, it bends over meaning to say, right, it no longer can behave elastically anymore. This part is what we call the deformed region. The deformed region. Okay. So in your exam, whenever they ask about Hooke's law, right, they'll either ask about two things only. Define Hooke's law, or they ask you to write the formula. Okay. If they ask you to define, guys, pay attention. Look here. If they ever ask you to define Hooke's law, if you can remember this graph, you can bullshit your way through the whole definition already, because Hooke's law states that the force exerted on a spring is directly proportional to the extension, provided that the elastic limit is not exceeded. I repeat, look at this graph. Hooke's law states that the force is directly proportional to its extension, provided that the elastic limit is not reached. So that's why, right, if I want to be very, very specific, this region here obeys Hooke's law, this whole part here, because it's directly proportional, right? And in other words, this region here doesn't obey Hooke's law, right? It doesn't obey Hooke's law because it's no longer directly proportional. Okay, before I move on, anyone's got any questions from this part here?
Okay, Hooke's law states that the force of the spring is directly proportional to the force exerted, to be provided the elastic limit is that's the definition.
Yeah, which is not stated. Okay, so this is one thing. You must know how to define Hooke's law. The second thing is you must know how to use the formula. Hooke's law has a very simple formula. F is equals to kx. Okay, this F is measured in force, which is obviously in newtons. This K is the spring constant. And this X is basically the extension, which is measured in meters. Okay, first question I want to ask you guys. Hey, everyone, don't copy first way, listen here first way. What's the units for spring constant? How do I know? Guys, this is one of a pro tip, guys. In physics, you'll be asked to write a lot of random units that you probably never heard about before. Like for example, how the hell am I supposed to know what's the units of spring constant? But you can use mathematics to solve the equation. Okay, for example, if let's say today I have something like 4/2 multiplied by 2. I know that the answer is definitely going to be 4, right? Because this and this cut away, right? Right. Everyone knows this, by the way. If you don't know, then you need to go for maths class. It will be the same thing here as well. Today, if I just look at the units itself, this is newtons, right? Is equals to the one that I'm looking for. I don't know what is it. Multiply by meters. Okay. Then what multiply by meters is supposed to give me newtons? Can anyone tell me?
Bracket unit equals m over m minus n.
N minus m.
Like you move the m to the over there, and then you move like the bracket unit back there. Like whether like since n is not like not times or divide, it's just either plus or minus, so it is equal to l, then it becomes n minus n.
N minus m.
So m minus n.
N minus n lagi like this.
And then like the bracket you move to the other side.
Then bracket move to the other side lagi, which is here. Wait, is that how you do algebra, Nani? You tell me how do I do this algebra?
No.
This is definitely wrong, okay? So it's out already. How do I do this? That's more logical, right, bro? This is like, bro. How do you even end up to minus, bro? So it's definitely supposed to be n over m, right? Is equals to that bracket thing that that you were looking for, Jim. Javen, what's going on? Okay, so if you think about it logically, then shouldn't Spring's constant be Newton per meter, right? Which fits the profile, right? Because if I know that Spring constant is Newton per meter, this thing is gonna cut to end up to give me newtons, right? Now in your physics, this is a very, very, very important skill. It's like a cheat, right? Because I can tell you, if your school teacher is telling you that you better memorize this unit, Spring constant is Newton per meter, right? Yeah, you'll memorize it probably for that class. Then exam come, you're like, shit, I don't know what to do already. Because shit, no one is really going to memorize all this random nonsense, right? It's better that you know mathematically how to find it, which is all derived from newtons per meter multiplied by meter is supposed to give you newtons, right? So it's the same thing here. So if next time in your exam you ever forget about what spring constant, right? You just write spring constant as the subject, which will give you F over X, right? You know for a fact that force is measured in newtons and extension is measured in meters. Then I know for a fact that this will be Newton per meter also.
Doesn't remember.
You don't remember?
What's that?
Okay, one more pro tip also. Everything to do with length, the SI unit is measured in meters one. Length is measured in meters, extension is measured in meters, amplitude is measured in meters, wavelength is measured in meters. Anything that has to do with how long an object is will be measured in meters. Okay, so in this case, extension, I'm extending how long, right? Then meters. Okay, everyone. Very important. Okay, so one more thing I want to ask about is, if I know that force is extension, F is force and X is extension, K is spring constant. What is actually spring constant? What is the spring constant? Let's imagine today I have two springs, one which is 100 Newton per meter and one which is 200 Newton per meter. My question will be, which one is the stronger spring and why? I got why? No, not exactly the answer I'm looking for. Which one is the stronger spring and why? Take a guess and why?
Take a guess.
No.
I don't know, probably 200.
Why?
Because it's bigger.
Okay, not exactly the answer I'm looking for. So you? Which one is the strongest one? Why?
So I think 200 newtons per meter will be the stronger one because think about it, there's 200 newtons in every meter.
Very close, but not exactly. You? Take a guess and tell me why.
Yes.
100 or 200 and why? Why do you pick it? Okay, why? Okay, very close, but not exactly also. Finally, you 100 or 200 and why? Why?
The bigger the better.
Okay, I want you to imagine. Have you all ever seen the spring on the car before? Have you guys ever seen something like that before? A spring on the car?
Oh,
It's called an absorber. Yeah, the wheels there. Have you guys seen it before? Okay, never mind. Never see it, right? Let me show you right now.
I've seen that before many times.
Shit. Have you guys seen something like this before? Like something like this lah. Anything to do with something like this? Or yeah, this one lah. You see that video. You guys You guys seen something like this before or not? Ever or not? Ever in your life? Do you know that?
I saw that.
Okay, that's good enough already. Guys, let me ask you this. Do you think this car has a high spring constant or low spring constant? And why? You say low, you say high, you say high. You? High or low? 点都是什么意思哦 Yes, high or low? High, okay. Guys, let me tell you this car spring which is what we call the absorber for sure it will have a damn high spring constant. Why?
This is force.
Yes, because if you think about it, let's imagine a normal car that can usually fit at least 4 people. 4 people, all of them average is 200, let's say 550 kg, which is a very bare minimum already. That will be at least 200 kg, right? This spring not only has to hold the weight of the car and its component, it has to hold at least 200 kg of passengers, and guys. Now, what does this mean? Today, if let's say this spring is very weak, right? It means to say it's very easy to compress, right? Compared to a very strong spring, means to say I have to use a lot of force to compress it, right? This here is exactly how you use the spring constant, guys. Based on the units itself, guys, based on the units itself, most of the time in physics, you can tell a story already. Because if I compare these two springs, this spring here needs 200 newtons to compress or elongate the spring by 1 meter. Whereas this spring here, I only need 100 newtons to compress or elongate the spring by 1 meter.
The spring thing for the car, is it true that sometimes
most cars will have 4 at least. At least. Get it or not, guys? So actually, right, the spring constant tells you how much force is needed to compress or elongate one spring, guys. And of course, the higher the spring constant, the higher the strength of the spring. You get what I mean or not, guys? You don't just look at it in terms of its numbers and units. You need to more or less ask yourself, why is it this specific units and why is it this specific number? Okay, everyone? So this is the thing I want to do. Guys, do you have any questions for this spring constant here? Or everything related to Hooke's law? Anyone has any questions or not before you start copying? Please start copying. Once you're done copying, attempt the 4 questions at the bottom.
go for it? It's like the X, like the n equals n over n.
That's not needed. I it's of pretty constant. Then n is for force Newton per meter is for pretty constant and meter is for expansion. But the topic question, if you did not have the formula, you possibly in difference it.
Then we perfect
Then we'll tell you so
um,
write the formula down.
formula. So we will another formula. So this kind of
Yeah,
what the and not be the
yeah, and your answer is correct, but for like every question.
oh. So it's like the right way. Isn't the formula like this and just like summing the values?
That's not a formula, that's a number. Formula.
And it was ten
doing here.
很吵哎，吵到我。就好大。对呀，还他三我他就快吵到我。但他拆了，所以我找到你的我不分心。绿色绿色的，那另外的地方红的。Yeah. If every person was formula, then people students and people students. This is what you got.
Why you having good? Why you doing wrong? What A? Coming from A.
Oh wait, now it's off the string of the night.
So good thing that string
You get it.
do this.
Live and exit live. Because I really
What are you looking for this question?
the screws.
Maybe for any track to actually right? So should you make something here instead of that? Or
So you want to rearrange the movement down to okay. Manage you should have said
this is wrong. So what does K mean?
is the
What does K now again, if I know a question including this PKN what does K mean?
isn't it ends over them.
Okay, well, I want you to relate now. Okay, let me ask you one simple question first. How many grams is 1 kilogram? 1000, right? What do you call kilogram? What's the unit for kilogram? kg, right? And gram is kg, right? So if I say 1k Newton, how many newtons is that? 1000. Very good.
So it's 50,000 inside a meter. 50,000.
50,000 newtons. You'll need the K very often in the exam as well, guys. Make sure you do not ignore it.
Thanks. Wait, string constant is something every meter.
Sorry, what?
String constant is like something Newton every meter. It's
Yeah,
already.
spring constant will be measured in newtons per meter. Mm-hmm.
My relationship is very good.
Sorry, what?
Very good relationship to because F equals KX and the frequency is K.
This is how you do algebra, man. I notice a lot of students they do the same thing. Why? Not only you know, like a lot of my students, right, when I ask them to do algebra, they all do it. And hey guys, for those who are struggling with fractional algebra, pay attention here. If I put numbers here, you for sure will know, right? For example, if let's say 8/4 is equals to what? Oh, 2, right? If I want to make 8 the subject, if I want to make 8 the subject, do I go like 8 equals to 2/4? Why not?
This is wrong.
Because it's wrong. So if I have f equals to kx, right? Which one goes at the bottom and which one goes on the top if I want to make k the subject? What is it?
It's F over X.
F over x, because this x, hey, look here, this x should go at the bottom, right? Then after that, in reality, it will be something like f over x is equal to k. Then you write k equals f over x now, but if you're good enough with algebra, you don't have to do that anymore, right?
Okay.
Okay. Yeah. 你看好你这边这个毛，你这边也能，但你中国这边就变成有的啊，是那个，每个人都自己是没错，哎，那边外你的那比来，我不要听你讲，就东西讲，你讲好你讲，不应该的，然后你背了，背也其实我。
那我滚。你有想去滚？哎，这里的太忙，真的会有人吃的。
Okay, let's go through the answers since most of you guys are done.
I was a bit scared when you say you work with the guy.
Okay guys, as I mentioned I want you to do your formulas because this will actually accumulate to your later on. Then you don't have to have so much answer from the students. Anyways, they ask you to find the force, right? So straight up you're going to find that F is equal to kx. Because you identify this as your k and this as your x, guys. Right? And straightforward law, F will be equal to 5 multiplied by 5, which will be 25 newtons easy. Now, the second one, you notice that this is in kilonewtons, so in reality, your force is 50,000 newtons. This is your force, right? They already give you the extension and they ask you to find the spring constant. Right, so you need to make spring constant the subject. K would have been equal to F over X or F divided by X, however way you want to write it. And that will give you 50,000 newtons divided by 5, which is going to be 10,000 Newton per meter. Okay, very straightforward. Then after that, once again, you identify your information. This is K, right? And this is F, right? Then they ask you to find what's the extension, right? So you make extension the subject, which will be F over K here, which is going to be 10 divided by 10, which is going to be 1/3. Easy, straightforward. Right? And finally, this last part here, can I just multiply them? Why not? Very good. I need to change this into cm, right? Which is going to be my extension, and this is going to be my spring constant. And once again, F is equal to kx, and it will be 5 multiplied by 1, which is going to give you 5 newtons. Yes, really, the max really.
Wow.
Hey guys. Yeah, I'll stop here today.
Wow.
Guys, next week when you're back, we're going to continue with this chapter and hopefully we can finish this chapter. No homework for this week, guys.
告诉你人生
谢谢你，我也是这样子觉得。
man
But next week when you come back, for sure you can expect some homework.
so you can donate it to the orphanage.
Yeah, here's some physics for